All right, sorry about that. We got caught off on the last video. So question 8 says, are the two triangles in the diagram similar? And the answer is yes, they are similar. And how do we know that? We're using that shortcut called SAS. Now, since we have a SAS for congruence, we have to be a little more specific here. So we're going to say that that is SAS similarity. So no longer just SAS. Make sure you add the word similarity. The last question says, what is the scale factor? And remember, anytime you write a scale factor, it's the image over the pre-image, which is how we set up our ratios here. So all we need to do is tell the simplified version of those. 30 divided by 3 is 10, 40 divided by 4 is 10. That means my scale factor is 10. That means my figure got bigger, which it did. That figure got bigger by a scale factor of 10. So question 9 in our notes says, how can we use the diagram above to find the distance across the pond? So that means, remember, this whole triangle is on the ground. If we can measure this side right here, the third side of the triangle, then we would use our scale factor to find out the new distance, which is the distance across the pond. So in number 9, we would have to measure the third side of the small triangle. And multiply by our scale factor, which is 10, to find the distance across the pond. So measuring that third side, multiplying it by 10 would get me the distance across the pond. All right, so in question 10, we're stating that the polygons are similar, so we'll have to say yes or no. If they are similar, we're going to write what similarity postulate we used and what is the scale factor. And then we're going to write a similarity statement. So if they're similar, we have to say yes, the similarity postulate, the scale factor, and write a similarity statement. Now, for some reason on our notes, that same figure is, our pair of figures is on there twice. We're really just doing it one time, so it's not two separate problems here. So when I'm testing to see if they are similar or not, I don't have any angle measures that are given to me. So I know I'm not going to be using the shortcut AA because that requires angles, or SAS because that requires angles as well. So really my only option for a similarity postulate to use here is SSS, sorry. So I've got to look and see if all three pairs of sides are proportional. Now if they are, I'm going to have to get the scale factor. So when I write my ratios, I'm going to go ahead and set them up as though I'm writing a scale factor. So I'm going to go ahead and put the image over the pre-image. And remember, we're assuming the first triangle given is the pre-image. That's the one we're starting with, and this is my image of it. So when I'm putting the ratios, I'm always going to be putting these sides on top of these sides in my fraction. Now, how do I know which sides to coordinate with? Remember, just like we did in the pond scenario, we're going to compare the longest sides together, the smallest sides together, and the medium sides together. So the longest side of this triangle is 18, and that's my image. I'm going to put that in the numerator. And I'm going to compare it to the longest side of the other triangle, which is 12. So I'm putting that in the denominator. The next largest of the big triangle is 15, and I'm going to compare that to the medium side of this triangle, which is 10. And then the smallest side of this triangle is 12, and I'm going to compare it to the smallest of the other one, which is 8. Now, again, you have two different ways to see if these are proportional. You could check all of your cross products and see if they are the same, or you can reduce all the fractions and see if they reduce to the same thing. Well, since I'm going to have to find my scale factor anyway, which would be the reduced form of those fractions, that's typically the way that I go about that. And so you can use your calculator to help you with that too. And so you can just do 18 divided by 12, and when you get a decimal, remember, just hit math, enter, enter, and it tells me that reduces to 3/2. 15 divided by 10 is also 1.5, which reduces to 3/2 as a fraction, and 12 divided by 8 is also 1.5, so of course that's also going to be 3/2 as a fraction. So that tells me, since all of these side pairs are the same exact ratio of 3/2, that yes, all three sides are proportional. So I'm going to answer all these questions. State if the polygons are similar. Yes, they are. If they are similar, what similarity postulate did we use? We used the three side pairs and proved they were all proportional. So we used SSS, similarity. Remember, we can't just say SSS or someone will think we're talking about congruence. What is the scale factor? That is the fraction all of those reduced to, which is 3/2. Since that's bigger than 1, that implies my figure got larger, which it did. And finally, we're going to write the similarity statement. So just like with a congruent statement, we have to show the corresponding parts. So if I name my first triangle ABC, and I'm not using a congruent symbol here, I'm using a similar symbol, we're going to name our second triangle showing those corresponding parts. So side AB, well, we could look at this angle A. Usually the angles are easier. A is between the side that was the medium side and the largest side. So between the medium and the largest here is angle D. B was between the smallest side and the largest side. So between the smallest and the largest here is E. And of course the third letter would be F. Okay, so next on here is your number 15 and 16 from last night's homework. And so I do want to look at that with you for just a minute, just to talk about some important things. So this is 15 and 16 from your homework, what was that, 12.5, 12.6. So on this, it tells us that triangle ABC, the small triangle, is similar to the ADE, the large triangle, and we're supposed to find the values of X and Y. So Y is the angle, and so if these are similar to each other, we can go ahead and find, well, we don't need them to be similar to find this, but we can use the triangle Sum Theorem here on these three angles, adding to 180. Add the 83 and the 36, and we get 119. And so if we take that away from 180 degrees, that leaves us with 61 degrees for this angle. Now I want you to notice that since this angle is 61 degrees and that angle is 61 degrees and they're corresponding angles, since they're congruent, that really means that this side is parallel to this side, is what we just learned. But Y is the linear pair to that 61 degree angle, and so to find Y, you needed to subtract the 61 from 180, and that gives us 119 degrees. You also could have recognized this as an exterior angle. I'm sorry, I could make this large for you, sorry. You can also recognize this as an exterior angle, which is equal to the sum of its remote interior angles. So either way, you should have found Y to be 119 degrees. Now, finding X, a common mistake that students will do is set up their proportion of these sides as 2 over 3 and then setting up 6 over X. Or another one that is incorrect would be 2 over 6 equaling 3 over X. And so I want to talk about why both of these are wrong. So when you're setting up the 2 over 3 as your ratio, 2 is a side of the small triangle, but 3 is not the side of the large triangle. It's part of a side, but it's not a side. So same thing here. You're doing two sides of the small triangle, but when you get over here, this is not a side of the large triangle. So the problem in both of those proportions is using the 3 when you should not be. What you really need to be using is the side of the large triangle here that you have to add the 2 and 3 to get. So the side of the large triangle is 5. So now when we set up our proportions, we can either put the 2, which is the small triangle side, over the 5, the large triangle side. So we're doing small triangle over large triangle. So when we set up the other ratio, we would put 6 over X. Or if you want to put your two small triangle sides together, you would put 2 over 6, but then your two large triangle sides would be 5 over X. So we can correct that by changing these 3's, which is not a side of the large triangle, to a 5, which is the side. Now you could also do the same thing over here, but again, we're not going to be using the 6. We would use the sum of 4 and 6 for that side, which is 10. So now when we cross multiply here, 2x equals 30. So 2x equals 30, dividing by 2 gives me x is 15. Same thing here, 2x equals 30 means x equals 15. So I just wanted to go over that problem with you. So remember, if we know that two sides of one triangle are proportional to two sides of another, is that enough to say the triangles are similar? Is two sides enough? SS. Do we have a shortcut called SS similarity? No, we do not. We either have to know the included angle is congruent to the included angle of the other, or we also have to have the third pair of sides as being proportional. So SS is not a shortcut. We have SSS and SAS and AA. So I do want to point out one thing on your homework tonight, just to clarify some directions on it. On 7 through 15, you have all of these different triangles that are lettered, and you're finding two that are similar and telling which postulate makes them similar. So if you find that, and here on the example on the board, I'll just show you that. It tells you to write your pairs in A, B, C order, in alphabetical order. So if you find A and F are similar, D and B are similar, and I and C are similar, you would write A and F first, and then instead of writing DB, you would write BD, and then instead of writing IC, you'd write CI. So just make sure that the first letter of each similarity is the first one that comes in the alphabet. So don't write IC here and then AD here. A comes first, so you'd write that here. And then don't write IC when C comes first in the alphabet. So everything should just be alphabetized, just so we're all getting the same answers. All right, good luck.